Hey there everyone, Ramesh here, back again with another video. In this video tutorial, we'll learn how to build the CRUD RESTful web services using Spring Boot, Hibernate and PostgreSQL database. In this project, we are going to use 3-layer architecture: controller layer, service layer and repository layer. At a database level, we are going to use PostgreSQL database. And controller layer basically holds the REST APIs and that will handle all the requests that comes from the client. Next, service layer basically holds the business logic of the application. Next, repository layer holds the database related logic and it is responsible to talk with the database. And in this tutorial, we are going to use Postman client to test the REST APIs. And in this project, we are going to use the latest version of Spring Boot, Hibernate, Spring Data JPA, PostgreSQL database, Maven, Java. Okay, we are going to use the latest version of all the tools and technology. Without further ado, let us start creating the Spring Boot application. Hi everyone, welcome back. In this lecture, we are going to create and set up Spring Boot project in IntelliJ IDEA. Well, first, we'll create a Spring Boot project using Spring Initializer and then we'll import that project in IntelliJ IDEA. So let us first go ahead and create a Spring Boot project using Spring Initializer. Well, here I am in a Chrome browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a tool that we can use to quickly create a Spring based application. So here, let us fill up the project information. So here we have different types of projects. So let us select Maven over here. And here we have different JVM languages, Java, Kotlin, Groovy. So let us keep Java as selected over here. Next, let us choose Spring Boot version. Well, here you can see by default 3.1.0 is selected. But whenever you create a Spring Boot project, then that time the Spring Boot version may be different. And let us keep the default one selected as it is because this is a stable and latest release of Spring Boot. Next, let us fill up the project metadata over here. So let us give group as net.javaguides. You can give any group that you want. Next, artifact. So let us give artifact as EMS backend. So here we are developing employee management system. That's why the name EMS and then backend. Next, project name is same as artifact. Next, let us give description as demo project for Spring Boot employee management system. Next, package net.javaguides.ems. Packaging, let us keep jar as selected. Next, Java version 17. Well, remember, whenever you choose Spring Boot 3, then make sure that you choose Java version 17 or later. Next, let us go ahead and let us add the dependencies. So go ahead and click on add dependencies over here and here just type web. Well, we use Spring Web dependency to build web applications as well as RESTful web services, and this Spring Web dependency internally provides Apache Tomcat as a default embedded container. Alright, so whenever you want to develop the Spring Boot RESTful web services, then make sure that you choose Spring Boot starter web dependency. Next, let us go ahead and let us select Spring Data JPA dependency. Well, we are going to use Spring Data JPA dependency to develop the persistence layer or the repository layer, and Spring Data JPA internally uses Hibernate as a JPA provider, and Spring Data JPA, it reduces a lot of boilerplate code that is required to develop the repository layer. So let us go ahead and select Spring Data JPA over here. Next, let us add a PostgreSQL JDBC driver dependency. Well, PostgreSQL driver is a JDBC and R2 JDBC driver that allow Java programs to connect to a PostgreSQL database using standard database independent Java code. Next, let us add a Lombok annotation. So here just type Lombok. So Lombok is a annotation based library which helps to reduce the boilerplate code. So let us select Lombok dependency over here. So as of now, let us keep these 4 dependencies for this Spring Boot application. And next, go ahead and click on generate button over here. So this will generate the Spring Boot application as a zip file and it will download it in a file system. Okay, next let us go ahead and let us open this zip file in a folder. Alright, next let us go ahead and let us unzip this zip file. Perfect. Next, let's open the IntelliJ IDEA over here, and here you can see we have 3 options: new project, open, get from VCS. So we are going to open the existing Maven project. So let us click on open button, and next go to the location where your Spring Boot application is present. So in my case, it is in download folder, and here let me select EMS backend project, click on open. Now we have opened Spring Boot application in IntelliJ IDEA. Well, let me recap what we have done in this lecture. We have created Spring Boot project using Spring Initializer, and then we have imported that project in an IntelliJ IDEA. In next lecture, we will configure PostgreSQL database in our Spring Boot application. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will configure PostgreSQL database in our Spring Boot application. Well, in order to connect our Spring Boot application with the PostgreSQL database, we have to configure the PostgreSQL database details in a Spring Boot application. So let's go to our Spring Boot application, go to application.properties file. So before configuring PostgreSQL database details over here, let's first create a PostgreSQL database. So let us head over to pgadmin4. This is the console to connect to the PostgreSQL server. So here right click, create and database. Let's give a database name as EMS. EMS stands for Employee Management System. So let us keep default and click on save. This will create a EMS database in a PostgreSQL server. Okay, next let's configure this EMS database in our Spring Boot application. So let's go back to IntelliJ IDEA, go to application.properties file. Here let us type the property spring.datasource.url. Next let us give the JDBC URL, JDBC PostgreSQL localhost. Well, the PostgreSQL server is running on localhost, local machine, that's why localhost, and the default port 5432 followed by the database name. So this is the JDBC URL to connect our Spring Boot application with the PostgreSQL database. Next, configure the username spring.datasource.username Postgres. Next, similarly, let's configure the PostgreSQL database password spring.datasource.password Postgres. Well, in my case, the username and password are same, so make sure that whatever the username and password you have given while installing the PostgreSQL database, you have to mention over here. Alright, next let's configure one more property spring.jpa.hibernate.ddl-auto equal to update. Well, this property is pretty useful. This property basically tells Hibernate to automatically create the database tables. Okay, so we don't have to manually create the database tables. Hibernate will automatically generate the database tables based on the JPA entities. In next lecture, we will create a employee JPA entity. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create an employee JPA entity. So let's go to our project in IntelliJ IDEA. And here, before creating the employee JPA entity, let's quickly create a packaging structure for our Spring Boot application. So go to base package over here, right click, new, and then choose package. Let's give package name as entity. Next, let us create one more new package. Let's call it as controller. Within a controller package, we keep all the Spring MUC controllers, and within the entity package, we keep all the JPA entities. Next, let's create one more package. Let's call it as repository. Within a repository package, we keep all the Spring Data JPA repositories. Next, let's create one more package. Let's call it as service. Within a service package, we keep all the interface and classes that are related to service layer. Next, let's create one more package. Let's call it as DTO. Within DTO package, we keep all the DTO classes. Next, let us create one more package. Let's call it as exception. Within exception package, we keep all the custom exceptions. Alright, so as of now, let us keep these packages. Next, go to entity package, right click on it, new, and then choose Java class. Let us give class name as employee. Alright, next let us go ahead and let us add the instance variables to this class. So here private long id, and then private string first name, and then private string last name, and then private string email. Perfect. Next, let us go ahead and let us use Lombok notations to reduce the boilerplate code. So here let us use @getter Lombok notation to generate the getter methods for these instance variables. Next, let us use @setter Lombok notation to generate a setter methods for these instance variables. Next, let us use @noArgument constructor notation to create a noArgument constructor. Next, let us use @allArgs constructor to create a parameterized constructor. Okay, now we have created employee Pojo class. let us make this employee class as a JPA entity by using JPA annotations. So let us annotate this class with add entity annotation from jakarta.persistence package. Well, we use add entity annotation to specify a class as a JPA entity. Next, let us annotate this class with add table annotation from jakarta.persistence package. Well, we use add table annotation to specify the table details. So here let us use name attribute to specify the table name. So let us give table name as employees. Perfect. Next, let us configure the primary key for this employee entity. So here let us annotate the ID field with add ID annotation. So make sure that you choose ID annotation from jakarta.persistence package. Next, let us configure the primary key generation strategy. For that, let us use add generated value annotation. And next, add generated value annotation has a strategy attribute. So here let us configure the primary key generation type. So here let us use add entity. So this identity primary key generation strategy basically uses database auto increment feature to automatically increment the primary key. Okay. Next, let us use add column annotation to map a database table column with a class field. For example, here let us have a column mapping for this first name field. So let us annotate this first name field with add column annotation from jakarta.persistence package, and let us give the column name first_name. So this column name will be mapped with the first name field. Okay, perfect. Well, if we don't specify add column annotation, then by default JPA will give the column name as field name. Okay, but the column name like first_name makes sense. That's why here we are using add column annotation to explicitly configure the column name for this field. Okay, perfect. Next, let us annotate last name field with add column annotation, and let's give column name as last_name. Next, let us annotate email field with add column annotation, and let us give a column name as email_id. Next, let us make this email_id column as a not null by using null label equal to false attribute, and we can also make this email as a unique by using unique equal to true. Alright, now we have created employee JPA entity. Next, let us run our Spring Boot application and let us see whether Hibernate will automatically create this employees table in a database or not. So let's go to main point class over here. From here, let us rerun the Spring Boot application. Next, let us go to the pgadmin4 and let us see whether the employees table is created in a PostgreSQL database or not. So let us head over to pgadmin4 here and go to EMS database, refresh, and go to schemas. Within a schemas, go to public, and within a public, go to tables, and within a tables, you can see employees table is successfully created. Next, right click on employees table and click on view data, and notice here the employees table has a column ID, email ID, first name and last name. Okay, it means Hibernate successfully created employees table in a PostgreSQL database. In next lecture, we will create a employee repository for this employee entity. Alright, I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have created employee JPA entity. In this lecture, we are going to create employee repository. So let's go to our project in IntelliJ IDEA and go to repository package over here. Right click on repository package, new, and then choose Java class. Select interface. Let us give interface name as employee repository. Next, let us extend this employee repository interface from JPA repository interface and make sure that you choose JPA repository interface from org.springframework.data.jpa.repository package. Well, notice here JPA repository is a generic interface, so we have to pass two parameters. First parameter is the type of the entity, second parameter is the type of the primary key. So let us select JPA repository over here and let us pass the parameters. First parameter as a type of the entity, in our case employee entity. Next, let us pass the type of the primary key, that is long. Well, if you go to employee JPA entity, you can see here we have given the type to the primary key ID as a long. So this long data type we are passing to JPA repository as a second parameter. Okay, perfect. Well, once our employee repository interface extends JPA repository interface, then this employee repository will get a CRUD methods to perform CRUD database operations on this employee JPA entity. Alright, so if you go to JPA repository interface source code, you can see JPA repository interface provides these methods, and again JPA repository interface extends list CRUD repository interface, and list CRUD repository interface provides all these methods, and this list CRUD repository method internally extends CRUD repository interface, and this CRUD repository interface exposes CRUD methods to perform CRUD database operations. Alright, it means this JPA repository will inherit all the methods from all the extended interfaces, and again Spring Data JPA will provide the implementation for this JPA repository interface. For example, if you click on this, you will get the implementation classes, and here simple JPA repository is a class that implements all the methods of JPA repository interface and its child interfaces. So just click on simple JPA repository class over here, and you can see simple JPA repository class implements JPA repository implementation interface, and this interface internally extends JPA repository interface. It means simple JPA repository indirectly implements JPA repository interface and its methods. Alright, and if you can notice here, simple JPA repository class, it is already annotated with add repository annotation, so we don't have to annotate our repository interface with add repository annotation. For example, if you go to employee repository, we don't have to annotate this employee repository interface with add repository annotation, because the implementation class, that is simple JPA repository class, is already annotated with add repository annotation. And here one more important point is simple JPA repository class annotated with add transactional annotation. It means all the methods in a simple JPA repository class are by default transactional. We don't have to use again add transactional annotation in a service layer to make the methods as a transactional. Okay, for example, if you just scroll down, you can see delete by ID method is a transactional because it is annotated with add transactional annotation, and delete method is a transactional because it is annotated with add transactional annotation. Alright, so all the public methods in a simple JPA repository class are transactional, so we don't have to again use add transactional annotation to make these methods transactional. Alright, just remember these couple of important points, like simple JPA repository is a class that implements JPA repository interface, and simple JPA repository class is already annotated with add repository annotation, so we don't have to again annotate our repository interfaces with add repository annotation. And simple JPA repository class is annotated with add transactional annotation, so all the methods, all the public methods in a simple JPA repositories are by default transactional. We don't have to again make those methods transactional by using add transactional annotation. Alright, perfect. So let me recap what we have done in this lecture. We have created employee repository interface that extends JPA repository interface. So this employee repository will get CRUD methods to perform CRUD database operations on employee JPA entity. In next lecture, we will create an employee DTO and employee mapper classes. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create an employee DTO and employee mapper classes. So let's go to our project in IntelliJ IDEA and go to DTO package over here. Right click on DTO package, new, and then choose Java class. Let's give class name as employee DTO. Perfect. Next, let us define the instance variables for this class. So here private long ID, and then private string first name, and then private string last name, and then private string email. Next, let us annotate this class with add getter lombok annotation to generate a getter methods for these instance variables. Next, let us use add setter lombok annotation to generate a setter methods for these instance variables. Next, let us use add no argument constructor and add all argument constructor annotations to create a constructors for this class. Well, we use employee DTO class to transfer the data between client and server. So when we build the RESTful web services, we'll use this employee DTO as a response for REST APIs. Next, let us create a employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. So whenever we build the RESTful services, then we have to convert employee DTO into employee JPA entity and employee JPA entity into employee DTO, right? So instead of writing the same logic in all the classes, let's create a mapper class and let's keep the common logic. So here what we'll do, we'll create a new package and let's call it as mapper. Let's create a class. Let's give a class name as employee mapper. And next let us create a static method, public static. Let's give return type as employee DTO and let's give method name as map to employee DTO. And let us pass employee JP entity as a parameter to this method. And next here return new employee DTO and let us pass the values to the constructor. So let us get all the values from employee JP entity and let us set those values to the employee DTO. So here employee dot get ID and then employee dot get first name, employee dot get last name, employee dot get email. Perfect. Now we have created map to employee DTO method. It will map employee JP entity into employee DTO. Similarly, let's create one more method that will map employee DTO to employee JP entity. So here public static, let us give employee JP entity as a return type. Next let us give method name as map to employee and let us pass employee DTO as a parameter to this method. Next return object. So let us construct the object of employee JP entity and here employee DTO dot get ID, employee DTO dot get first name, employee DTO dot get last name, employee DTO dot get email. Alright, perfect. Now we have created map to employee static method. It convert employee DTO into employee JP entity. Alright, perfect. So let me recap what we have done in this lecture. We have created employee DTO class to transfer the data between client and server, and next we have created employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. Alright, great. In next lecture onwards, we will start building the RESTful web services. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will build add employee REST API. Well, let us take a look into the development steps. First, we will create the service layer. Well, if you can see here, the controller layer depends on service layer and the service layer depends on a repository layer, and we basically create the REST APIs in a controller layer, right? So controller layer depends on service layer. So let us first create the service layer. Well, we have already created the repository layer, so we don't have to write any methods in a repository layer as of now. So let us first create the service layer and then we'll build the REST API in a controller layer. Okay, so create the service layer, like we'll create an employee service interface and then we create an employee service IMPL class that implements employee service interface. Next we'll build the add employee REST API in a controller layer, and next we'll test this add employee REST API using Postman client. Okay, so let us go to our project in Data JPA, and here let us first create the service layer. So go to service package, right click on it, new, and then choose Java class, select interface. Let us give interface name as employee service. Within employee service interface, let us define the method. So let us give method return type as employee DTO. Let us give method name as create employee and let us pass employee DTO as a parameter to this method. Perfect. Next, let us create employee service IMPL class that implements this interface and its methods. Next, go to service package, right click on this package, new, and then choose package. Let's give package as IMPL. IMPL stands for implementation. So right click on IMPL package, new, and then choose Java class. Let's give class name as employee service IMPL. Perfect. Next, this class implements employee service interface. And next, go ahead and mouse over on this class, and here you will get the option to implement the methods like the link. So go ahead and click on this implement methods link over here and select the method that you want to implement. Click on OK. Perfect. Next, let us annotate this class with @service annotation. and make sure that you choose service annotation from org.springframework.stereo package. Well, this annotation tells Spring container to create the Spring Bean for this class. Next, let us implement createEmployee method. Well, before implementing this method, let us first inject the dependencies. So here, private employee repository. Well, we are going to use constructor-based dependency injection to inject the dependencies, and instead of creating the constructor manually, let us use Lombok annotation. So let us annotate this class with @all-argument constructor annotation. Okay, now we have injected employee repository as a dependency. Next, let us implement createEmployee method. So go to createEmployee method, and within this createEmployee method, first we need to convert employee DTO into employee JPA entity, because we need to store the employee entity into database, isn't it? So here, let's say employee equal to, let us call employee mapper class to map employee DTO to employee JPA entity. So here employee mapper, it has map to employee method and then pass employee DTO. Okay, now we have converted employee DTO to employee JPA entity. Next, let us save this employee JPA entity into database. So for that, let us call employee repository. It has a save method and then pass employee JPA entity object. Perfect. Next, this save method return the saved employee object. So let us get into a local variable. So here employee, and let us give a variable name as saved employee. Next, we need to return saved employee object back to the client. So here let us convert saved employee JPA entity into employee DTO. So here let us remove this null and let us type employee mapper. It has map to employee DTO, and let us pass saved employee. Perfect. Now we have implemented createEmployee method. Next, go to controller package over here. Right click on controller package, new, and then choose Java class. Let us give class name as employee controller. Next, let us annotate this employee controller class with @REST-controller annotation. Well, once we annotate a class with @REST-controller annotation, then this class becomes a Spring MUC REST controllers, and this class is capable to handle HTTP requests. Next, let us annotate this class with one more annotation, that is @requestMapping annotation. Well, here we are using @requestMapping annotation to define the base URL for all the REST APIs that we are going to build within this controller. So here let us give the base URL /API/employees. Okay, perfect. Next, within this employee controller, let us first inject the dependencies. So private employee service, and instead of creating the constructor manually, let us annotate this class with @all-argument constructor annotation. Okay. Next, let us build add employee REST API. So here let me write the comment, build add employee REST API. Well, creating REST API using Spring Boot is very simple. First, we need to create a method, and then we'll make that method as a REST API by using Spring annotations. So here let's first create a method, public, and let's give return type of the method as a response entity. So response entity is a generic class. We have to pass the type. So here let us pass employee DTO as a type. Next, let us give method name as createEmployee, and let us pass employee DTO as a parameter to this method. And next, here let us call employee service. It has createEmployee method, and then pass employee DTO object as a parameter to this method. And this createEmployee method returns a saved employee. So here employee DTO, and let us give the variable name as saved employee. Next, let us have a return statement, return object of response entity. So let us pass value to the constructor. So first value as saved employee, second value as HTTP status code. So here just type HTTP status dot created. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @postmapping annotation. Well, we use @post mapping annotation to map the incoming HTTP post request to this method. Next, let us use one more annotation here, that is @requestBody annotation. Well, this @requestBody annotation will extract the JSON from the HTTP request and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have created add employee REST API. Next, let us run our Spring Boot application and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to the Postman client over here, and here let me create a new request. Let us choose HTTP post method and let us enter the request URL HTTP localhost 8080/API/employees, and next go to the body, select raw, select content of JSON, and within a body we need to pass the JSON object. So here let's create a JSON object. So first name, let us give first name as Ramesh, and then last name, let us give last name as Partari, and then email, let us give email as ramesh@gmail.com. Well, if you can go to our project in IntelliJ IDEA and go to create employee REST API, and here you can see employee DTO, and if you go inside employee DTO, and this employee DTO class has the fields first name, last name, email, and if you go to Postman client and if you can notice the JSON over here, the attributes name like first name, last name, email. So whenever you pass the JSON in the request, make sure that the JSON attributes should be same as the DTO class fields, because we are using @requestBody annotation here to extract the JSON and convert that JSON into employee DTO Java class object. And in order to convert a JSON into Java object, the JSON attributes and Java object fields should be same. Okay, perfect. Next, let's go to Postman client over here. Next, go ahead and click on send button, and there we go. We got a response of the REST API, and if you can notice here the status 201 created and the saved employee object in the response. We have successfully built add employee REST API. In next lecture, we will build get single employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get employee REST API. So let's go to our project in IntelliJ IDEA. And let us first change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let's go to employee service interface over here. Within this interface, let us define the get employee by ID method. So here, let us give employee DTO as a return type of the method, and let us give method name as get employee by ID, and let us pass employee ID as a parameter to this method. Perfect. Now we have defined get employee by ID method in a employee service interface. Next, let us implement this method in employee service IMPL class. So let us go to employee service IMPL class over here and just mouse over on this class, and here we have implement methods link. So go ahead and click on this link over here and then select the method that we want to implement. Next, click on OK. Perfect. So here we can implement the get employee by ID method. Well, before implementing this method, let's go ahead and let's first create one custom exception. Well, whenever an employee with a given ID is not exist in database, then we have to throw the custom exception, isn't it? So let us go ahead and let us first create the custom exception. So go to exception package, right click, new, and choose Java class. Let us give exception name as resource not found exception. Perfect. Next, let us extend this class from runtime exception, and then let us create a parameters constructor, public resource not found exception, and then let us pass message as a parameter. Alright, and here let us call super keyword to pass this message to the super class constructor. Next, let us annotate this class with @response status annotation, and let us specify the HTTP status. So here let us give HTTP status not found. Well, if employee with a given ID is not exist in database, then we will throw this resource not found exception, and then Spring Boot will catch this exception and it will get the error message from the exception, and it will send the error message along with the HTTP status to the client. Next, let us go back to employee service IMPL class over here. Next, let us implement this get employee by ID method. So here, let me maximize this. So within a get employee by ID method, let us call employee repository. It has find by ID method, and notice here find by ID method returns optional of type employee. So let us call find by ID method over here and just pass employee ID. Next, optional has or else throw method. So here let us call or else throw method over here, and notice here or else throw method returns a employee object, and or else throw method takes supplier as a functional interface, and we have to pass the lambda expression implementation of this supplier functional interface. So let us call this or else throw method over here, and let us create the lambda expression. So here lambda symbol and then new resource not found exception, and let us pass the message employee is not exists with a given ID. Alright, and let us pass the ID dynamically over here, that is employee ID. Perfect. Next, let me maximize this a bit. Next, you can see the type over here exists, so let me correct it. Employee is not exist with a given ID, and then employee ID. Next, let me also break this statement. Perfect. So this or else throw method returns an employee object. So here let us take the result of this or else throw method in a local variable of type employee. Perfect. Next, if you can notice here, get employee by ID method returns an employee DTO. So let us convert this employee JPA entity into employee DTO. So go to return statement, remove this null, and let's call employee mapper over here. It has a map to employee DTO method, and then pass employee JPA entity object. Perfect. Now we have implemented get employee by ID method in a employee service IMPL class. Next, let us create the REST API that will internally call this get employee by ID method. So here let me minimize this and go to employee controller over here, and within employee controller let us build get employee by ID REST API. So here let me write the comment build get employee REST API. Well, creating a REST API using Spring Boot is very simple. We just need to create a method, and then we will convert that method into REST API by using Spring annotations. So here let us first create a method public, and then response entity as a return type. Response entity is a generic, so let us pass employee DTO as a type. And next let us give a method name as get employee by ID. Next let us pass employee ID as a parameter to this method. Within this get employee by ID method, let us call employee service. It has get employee by ID method, and then pass employee ID. Perfect. So this get employee by ID method returns employee DTO. So here let us take the result of this method in a local variable of type employee DTO. Perfect. Next let us have a return statement, return response entity. It has a OK method, and next let us pass employee DTO as a parameter to this method. Perfect. Now we have created get employee by ID method. Next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Well, we use add get mapping annotation to map the incoming HTTP GET request to this method. Next let us pass the ID. Well, this ID is basically called a URI template variable. Next we need to bind the value of this URI template variable to this method argument. So in order to do that, we have to use add path variable annotation. So here let us use add path variable annotation, and we need to also pass the URI template variable name here, that is ID. So notice here the URI template variable name is ID and the method argument name is employee ID. So both the variable names are different. That's why we have to pass the URI template variable name to the path variable annotation. Then only the path variable annotation will bind the value of this URI template variable to this method argument. Okay, perfect. Now we have created get employee REST API. Next let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here I want to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postgres client over here and let us create a new request. And here let us choose HTTP GET method and let us enter the request URL HTTP localhost 8080/API/employees and then /1, and here we have passed employee ID 1. Okay, next click on send button and there we go. You can see the response. The REST API returned the response and the response contains the employee object in a JSON format and the status 200 OK. It means we have successfully built get employee REST API. In next lecture we are going to build get all employees REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build get all employees REST API. So let's go to our project in IntelliJ IDEA over here. And first we will change the service layer and then we will change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here, and within this interface let us define the method. So let us give a return type of the method as list of employee DTO. Next let us give method name as get all employees. Alright, now we have created get all employees method in a employee service interface. Next let us implement this method in a employee service IMPL class. Let us head over to employee service IMPL class over here and just mouse over on this class. Click on this implement methods link. Next let us select the method that you want to implement. Click on OK. Alright, now let us go ahead and let us implement this get all employees method over here. Within a get all employees method, let us call employee repository. It has find all method. We'll notice here there are multiple overloaded find all methods. We are going to choose the find all method. It doesn't take any method argument, and find all method returns a list of type employee JPA entity. Okay, so let us select find all method over here. Next let us take the result of this find all method in a local variable of type list. So here let us declare list. List is a generic. Let us pass employee class as a type and let us call it as employees. Perfect. Now we have list of employee JPA entities, but if you can see here get all employees method returns list of employee DTOs, right? So let us convert a list of employee JPA entities into list of employee DTOs. So here go to return statement, remove this null, and here just call employees. So employees is a list. It has a stream method and then stream has a map method, and notice here map method has a function as a functional interface, and we need to provide the lambda expression implementation for this functional interface. So let us select map method over here. So basically we use map method to map one object into another object, and in our case we have to convert employee JPA entity into employee DTO, right? So here let us have a lambda expression implementation. So here let us pass employee as a parameter and let us have lambda symbol and then call employee mapper. It has map to DTO method and then pass employee object. Perfect. And finally let us call collect method to collect the result. So here we are using list, so let us call this collect method. It takes to list as a parameter. Now we have written a logic to convert a list of employee JPA entities into list of employee DTOs. Next let us create the REST API that will internally call this method. So go to employee controller over here, and within employee controller let us build get all employees REST API. So here let me write the comment build get all employees REST API. Well, creating REST API using Spring Boot is very simple. First we need to create a method and then we'll convert that method into REST API by using Spring annotations. So here let us first create the method public response entity as a return type. Response entity is a generic, so let us pass list as a type. List is also a generic interface. Let us pass employee DTO as a type and let us give method name as get all employees. Alright, and here let us call employee service. It has get all employees method. So get all employees method returns a list of employee DTOs. So here let us declare a local variable of type list. List is generic. Let us pass employee DTO as a type and let us give variable name as employees. Perfect. Next let us have return statement return response entity and then call its OK method and then pass employee objects as a parameter. Perfect. Now we have created getAllEmployees method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add_getMapping annotation. Well, we use add_getMapping annotation to map incoming HTTP GET request to this particular method. Alright, perfect. Now we have built getAllEmployees REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postman client over here. And here, let me copy this URL and let me create the new request. Let us choose HTTP GET method and let us enter the URL localhost 8080/API/employees. Click on send button and there we go. You can see the array contains a single JSON object. So let us insert one more employee. So go to add employee request over here and let us change the JSON. Post name, let us say Sanjay. Last name, let us say Jadhav. Email sanjay@gmail.com. Next, click on send button and there we go. We got the response and the status code 201 created. Next, let us go to getAllEmployees request over here and then click on send button and there we go. You can see here there are total 2 employees and in a response also there are 2 employees. Next, let us insert one more employee. So go to post request and here let us give first name as Tom and last name Cruz. Email tom@gmail.com. Click on send button and there we go. We got the response with the employee ID 3. Next, let us go to getAllEmployees request over here. Click on send button and there we go. You can see a Tom employee is present in a array. Okay, it means we have successfully built getAllEmployees REST API. In next lecture we will build updateEmployee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build updateEmployee REST API. So let us go to our project in IntelliJ IDEA. Well, first we want to change the service layer and then we'll change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here. Within this interface, let us define the method. So here let us give employee DTO as a return type of the method and let us give method name as updateEmployee and let us pass employee ID as a post parameter and employee DTO as a second parameter, and this employee DTO basically contains the updated employee details. Okay, so let us call it as updated employee. Okay, perfect. Now we have defined updateEmployee method in an employee service interface. Next, let us implement this method in an employee service IMPL class. So let us go to employee service IMPL class over here. Just mouse over on this class, click on this implement methods and then click on OK method. Now let us go and let us implement updateEmployee method. Within updateEmployee method, let us first add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So let us write that logic here. So just call employee repository. It has find by ID method and notice here find by ID method returns optional app type employee. So let us call find by ID method over here and then pass employee ID as a parameter, and then optional has or else throw method. So let us call or else throw method over here. And notice here or else throw method takes supplier as a functional interface and we have to provide the lambda expression implementation for this supplier functional interface. So just call this method and then let us construct the lambda expression. So here new resource not found exception and then let us pass the custom exception message. Let us say employee is not exist with given ID and then pass employee ID dynamically. Perfect. Next, let me put the semicolon over here. Alright, and this or else throw method returns a employee object. So here let us take the result of or else throw method in a local variable of type employee. Perfect. Next, we have the updated employee object. It contains all the employee updated information. So let us set all the details from updated employee object into this employee object. Okay, so here employee dot set first name, and then updated employee dot get first name, employee dot set last name, and then updated employee dot get last name, employee dot set email, and then updated employee dot get email. Perfect. Next, let us call employee repository. It has a save method, and then pass this employee object. Okay, so here basically we have updated this employee object with first name, last name, email, and again we are saving this employee object by using save method. So basically this save method performs both save and update operation. Well, if employee object contains ID, then this save method internally perform the update operation, and if employee ID doesn't contain the primary key ID, then it will perform the insert operation. Alright, next this save method returns the updated employee object. So here let us declare the updated employee object like this. Perfect. Next, if you can see here, update employee method returns the employee DTO. So let us convert this updated employee object JPA entity into employee DTO. So here go to return statement, remove this null, and then call employee mapper. It has map to employee DTO method, and then pass updated employee object as a parameter. Now we have implemented update employee method in a employee service IMPL class. Next, let us create the REST API that will internally call this update employee method. So go to employee controller over here. Within employee controller, let us build update employee REST API. So here, let me first write the comment, build update employee REST API. Let us first create a method, and then we will convert that method into REST API by using Spring annotations. So here just type public response entity, and then pass employee DTO as a type. Let us give method name as update employee. Alright, and let us pass employee ID as a first argument and employee DTO as a second argument. So this employee DTO is nothing but updated employee information. Perfect. Next, let us call employee service. It has update employee method, and then pass employee ID as a first parameter, updated employee as a second parameter. Perfect. Next, this update employee method returns the employee DTO. So here let us have a local variable of type employee DTO. Alright, next let us have a return statement, return response entity, and then call OK method, and then pass employee DTO. Alright, now we have created update employee method. Let us make this method as a REST API by using Spring annotations. So let us annotate this method with @putMapping annotation. Well, we use @putMapping annotation to map incoming HTTP put request to this method. Next, let us pass the ID. So here is the syntax. Within a open and close curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use @path variable annotation over here. And next, let us pass the URI template variable, that is ID. Perfect. Next, we need to use one more annotation, that is @requestBody annotation. Well, this @requestBody annotation will basically extract the updated JSON from the request, and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have built update employee REST API. Next, let us rerun our Spring Boot application, and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us go to Postman client over here, and here let me copy this URL and let me create the new request. And here let us choose HTTP put method, and let us enter the request URL localhost 800/API/employees, and then we need to pass the employee ID that we are going to update. So let us say we are going to update the employee with ID 1. Alright, next let us pass the updated information in the body. So click on body raw content type JSON, and here we need to pass the JSON. So here let me quickly create the JSON. First name Ram and last name Jadhav, email ram@gmail.com. Next, go ahead and click on send button over here, and there we go. You can see the response. The post name is updated, last name is updated, and email is also updated. It means we have successfully built update employee REST API. Alright, great. In next lecture, we will build delete employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build delete employee REST API. So let's go to our project in IntelliJ IDEA over here. Well, first we'll change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let us go to employee service interface over here, and within this interface, let us define the method. So let us give void as a return type of the method, and let us give method name as delete employee, and let us pass employee ID as a parameter to this method. Next, let us go ahead and let us implement this delete employee method in our employee service IMPL class. So go to employee service IMPL class over here, just mouse over on this class, click on this implement methods, and choose the method that you want to implement. Click on OK. Alright. Next, let us go ahead and let us implement this delete employee method. So here, first of all, we need to add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So if you go to update employee method over here, here we have already written the logic. Okay, so let us copy this piece of code and go to delete employee method, and here just paste this piece of code. So here basically we are calling find by ID method, and this find by ID method returns optional. So again here we are calling or else through method of optional object, and here basically we are providing the lambda implementation of supplier functional interface. So basically, if employee with a given ID is not exist in database, then this piece of code will basically throw the resource not found exception. Next, let us call employee repository. It has delete by ID method, and then pass employee ID as a parameter to this method. Okay, perfect. So this delete by ID method will basically delete the employee by ID. Alright, next, let us create delete employee REST API that will internally call this method. So go to employee controller over here. Within employee controller, let us build delete employee REST API. So here let me write the comment first. Build delete employee REST API. So first we'll create a method, and then we'll convert that method into REST API by using Spring annotations. So here just type public and then response entity as a return type. So let us pass string as a type, and then let's give method name as delete employee. Alright, and let us pass employee ID as a parameter to this method. Perfect. Next, within our delete employee method, let us call employee service. It has delete employee method, and then pass employee ID. Next, let us have a return statement, return response entity dot OK, and let us pass the success message, that is employee deleted successfully, something like that. Perfect. Now we have created delete employee method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add delete mapping annotation. Well, we use add delete mapping annotation to map the incoming HTTP delete request to this method. Next, we need to pass the ID to this annotation. So here within a curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use add path variable annotation and then pass URI template variable name. Perfect. Now we have built delete employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman client over here, and here let me copy this link and let me create a new request, and here let us choose HTTP delete method, and let us enter the request URL localhost 800/API/employees, and here we need to pass the employee ID that we are going to delete. For example, let us say we want to delete the employee with ID 1, then we have to pass the employee ID 1 in the request URL, and go ahead and click on send button over here, and look at here the response, employee deleted successfully and the status code 200 OK. Alright, it means the delete employee REST API is working as expected. Alright, great. I will see you in the next lecture.